Welcome back. We're closing the day with a keynote from someone whose work is behind many of the tools we use every day. Winston Chang is a principal software engineer at Posit. He's the creator of R packages like R6, Provis, ShinyTest, and FastMap, and a contributor to key projects including Shiny, ggplot, and DevTools. He's also the author of the R graphics cookbook and leads development efforts on Shiny for Python and Shiny Live. You've probably noticed I've skipped a few names I always struggle to pronounce. Winston, it's great to have you with us. The floor is yours.
All right. Thank you very much, Pavel. Okay, let me see if I can bring up my screen share here. Okay, great. Thanks for having me. I'm going to be talking about Shiny and AI today. Now, I just want to start off by saying this is a very exciting time. I've been working with computers and coding for some time now, and there have been times where I've been excited about projects, and there have other periods where I've been kind of bored with things. But with AI and large language models, these are the most interesting and exciting technologies that I've worked with. It's been really fascinating to learn what they can do, and it's been fun to use AI tools to build things. So at Posit, we've been putting a lot of energy into AI in the last year, and certainly for the Shiny team, AI has been our main focus because we want our users to be able to build applications that use AI. And we recognize how important AI is right now, and that importance is only going to grow as time goes on. Okay, so here's the plan for this talk. I'm going to talk about building tools that we have for building Shiny applications that use AI. Then I wanted to talk about how LLM conversations work. Now, this is important. Understanding this is important for getting the most out of your AI tools. Then I'm going to cover AI assistants for building Shiny applications, and for fun, using AI assistants to build Shiny applications that use AI. Okay, so for building Shiny applications that use AI, there's really two parts of the software that are important that you need to know about. There's the back end. There's the libraries that communicate with the LLMs. And then there's the front end. There's like the chat UIs and chat UIs for Shiny. So for the back end, we have a number of LLM. Well, there's many options for LLM libraries in various programming languages, but in R, the one that we recommend using is Elmer. Now, development on Elmer started last fall by Hadley Wickham. There were not in the R world, there are not that many options for libraries that talk to LLMs, and Hadley has some, he has some strong ideas about how APIs should look, and they're usually pretty good ideas. So he started working on Elmer, and that is, so that's what we recommend people use in Shiny to be able to talk to LLMs like OpenAI and Anthropic. Okay, and on the Python side, we've developed chat lists. In general, in Python, there's a lot of development activity happening around AI. And so there's several options for LLM communication libraries in Python, but none of them were quite at the right level of abstraction for what we wanted. So some of them were pretty low level, like the libraries that OpenAI and Anthropic have put out are relatively low level. And then there's very high level ones like LangChain. And we didn't feel that those had quite the right level of abstraction for what we wanted to do and for what we wanted our users to be able to do. So we started working on chat lists. So Carson Sievert on the Shiny team has been leading the development on this. And the API for chat lists is heavily inspired by Elmer. So there's quite a few similarities between these two. And we think that these are at a good level of abstraction and simplicity for people to use and to be able to do interesting things with them. Okay. Now for the chat UIs, this is stuff that we've added into. These are things that we've added to Shiny or in R in a separate package. In R, there's the Shiny chat package, and in Python, we've put these components directly in the Shiny package as UI.chat. So this is what it looks like. So this is a pretty typical chat interface, but we're constantly working on making it better. This is a very active area of development for us. Now, let's see. So I'm not going to go talk about these in depth because there've been several talks about them. So I know Carson Sievert gave a keynote in the morning, or in the for me, a very, very early morning about these packages and building UIs with them. And I believe David Rapp also talked about some of these things. But I just want you to know they exist and what these names are so you can look them up and learn more about them. So now the next thing I want to cover is how LLM conversations work. So I think this is very important if you want to be able to get the most out of the AI tools that you build. Okay, so let's start off with how the communication works. So when you want to send something to an LLM and ask it a question, so you make an HTTP request with a prompt to an LLM server. So that might be at OpenAI or Anthropic, or maybe you're running something locally. All right, then that LLM server, well, it sends that text to the LLM, and then it responds with the answer. Now, one thing that you might find surprising about this is that the server is stateless. So the server doesn't remember anything about your conversation when you send something back to it in the future. And that is surprising. Like, how can you have a conversation with someone that has no memory during the conversation of what you're talking about? How does that work? I will say that this does have a lot of useful properties, though. This makes it much easier to program against an LLM because you don't have to manage synchronizing state or the state on the client and the server side. Every time you send a request, it's just you're sending a new request. It doesn't have to know anything about the past, or the server doesn't have to know anything about the past. I should say that. Okay, so let's look at some code here. This is what a chat request looks like, and this is using the curl command line tool. Of course, you can do the same thing in R or Python, but I'm just using this here because it's relatively simple. All right, so you visit this web API here, and you send it some headers. And then this is the interesting part. This is the payload that you're sending it. You tell it what model you want. In this case, we're using OpenAI's GPT-4o, and then you give it these messages. The first of these messages is the system prompt. In this case, we're saying you are a Terse assistant. And the system prompt in general is an instruction that the application author wants to send to the LLM that the user doesn't see typically. And that will guide the LLM's behavior. Okay, so there's that part that's sort of behind the scenes for the user. And then the user has their message. In this case, it's the user saying, write a haiku about data science. All right, so that gets sent to the server with the LLM. And then when the LLM finishes, or when the LLM finishes computing its response, it sends it back, and it sends a message like this. And this is the interesting part here. It says message role of assistant and content. I formatted this. This is obviously broken JSON if you know all about that, but I formatted it so it looks nicer. Numbers whisper truths, patterns emerge from chaos, insights bloom like dawn. Okay, that's really nice haiku. Now, let's say we want to continue the conversation. All right, and we want to take another turn in the conversation. So the user or the application sends another message to the LLM, and we have the messages here. So we start off with the same two messages that we sent last time. Then we also add in the assistant's response, which is a haiku, and then the user's query after that. Now make it funny. Okay, so we're sending this the entire message history to the LLM. And when it gets that, it'll respond. It might look something like this. Message role assistant, content, charts and graphs all day. AI thinks cats are croissants. Blame the intern's code. So that is how it works. You're constantly, every time you make a request to the LLM, you have to tell it what it said in the past, what you said and what it said in the past. And that's how it can be stateless. The server can be stateless. All right, so to recap, the conversation with an LLM is not a conversation between two stateful beings, right? If you're talking to another person, that's two stateful beings talking to each other, and they remember what was said in the past, and they have some sort of mental state that persists through the conversation. All right, so you have mental state that persists, but the LLM does not. And every time you send a new message to the LLM, you're also including the entire previous conversation. And at that point, the LLM responds with a completion that makes sense given the prior context. Right? And that's how these LLMs work. Now, the chat interfaces that you see with like the ChatGPT web application or Claude, they provide the illusion of a conversation with a stateful being, but that's not really what's happening behind the scenes. All right, now I'm going to show you a little demo here that sort of makes this really clear. All right, so this is a little AI chatbot I wrote with Shiny to play 20 questions. So that the chatbot's thinking of, it says, I'll think of an object and you ask the questions. So that's me, I'll ask questions about yes or no questions, trying to figure out what this object is. So I'll use this voice recognition thing on my computer. Is the object found in a house? Okay. Yes, it's found in a house. Great. Is the object found in a kitchen? Is it a utensil? Yes, it's a utensil. Great. I'm doing great here. Is it a spoon? No, it's not a spoon. Is it a fork? Yes, it's a fork. Congratulations on guessing. Would you like to play again? Now, every step in that conversation, I'm sending a new request to the LLM and giving it the whole message history. So, there's not some state at the beginning. Well, there might have been some state at the beginning where, who knows what's happening in the LLM, where it had some idea of what it was thinking about. But that was not the same LLM instance that I was talking to necessarily. And I'll show you, I added a little thing here that recorded the communication here. So here's the first message I sent. Is the object found in a house? It said yes. The model here is GPT-4o. Then I asked, is the object found in the kitchen? And this model is Claude 3.5 Sonnet. So I actually sent a request to a different LLM with the message, with the same with the continuing message history. And then for my next question, I sent it to yet a different LLM, GPT-4o Mini, and it gave me a response that made sense. And yet another LLM for the next step. So I kept doing that, just rotating through these 4 LLMs, and we have this what seems like a perfectly reasonable conversation, but it's not a conversation with like that you have with a person, where the person has something in mind that's persistent through the whole conversation. Every step of the way, the LLM is sort of making it up. All right, so I hope that really drives the point home. Okay, so the next concept that is important to know about is tools for LLMs. So LLMs themselves are just sort of text in and text out machines. That's really all they can do by themselves. They can't do anything else. There's stuff that's built around them that can do things. And one of the things that we do is that we can use is tool or function calls. So these tools are a way for LLMs to interact with the world. So the application, like the app that you write, sends the user request to the LLM along with a list of tools, all right? And the list of tools, they look like functions. So here's one, get weather, location, fetch URL, list files, control lights. So along with the user's request, your application will also send to the LLM, like, here's some things that you can do. Here's functions that are available for you. Okay, so let's quick look at a request that has tools. So we send that user message. If it's cloudy in Minneapolis, that's where I live. If it's cloudy in Minneapolis, turn on the lights. All right, so and we send along these 2 tools. This one's called get weather. This is a description of it, and then these are the parameters, location. All right, and this is how the LLM knows how to, what can this tool do, and how do I invoke it. We also give this other one control lights. All right, so control lights description, control lights for user's home, and the state is either on or off. Now, when the LLM receives that request, it'll probably want to find out the weather in Minneapolis. So if it decides that that is a useful thing to do, it'll reply with a tool call, and it's going to wants to call get weather and pass in the location as Minneapolis, Minnesota, USA. Okay, so just to recap those steps. The application sends the user request along with a list of tools. The LLM responds with a tool call if it thinks it's appropriate. Now, if the application, this is your R or Python code, if it receives a tool call, it'll execute the function. So there's some function that you've written to go fetch the weather, to find the weather from like a weather API. And the application sends the result back to the LLM along with the message history, and the LLM will either respond with text or another tool call. So in this case, it'll probably it'll find out it's cloudy today, so it'll probably make another tool call to turn on the lights. All right. So, but the application is responsible for actually doing those things, for actually turning on the lights. And so this cycle just will repeat as long as there's any tool calls remaining. All right. So that is how LLMs can interact with the world with tool calls. And this is supported by Chatless and with Elmer. Okay. Now prompt engineering. I'm just going to give a really brief overview here. So by prompt engineering, usually we mean modifying the system prompt for the LLM. And one of the things that we can do with this is to customize the behavior. Like you can tell it, speak like a pirate, or if the user asks data questions, provide R code, or extract a recipe from text and return it as JSON. All right, so those are things you might do in your system prompt and to customize its behavior. But you can also teach the LLM new things. So, by teaching, I just sort of mean in that when it's giving the response, that one response, it's not really learning things long term. Okay, so for teaching LLMs, you can use something called prompt stuffing. So that's basically just adding documents to the system prompt. All right, and I'm going to show you one way to do this with Elmer Assistant. So when Elmer, we first started using it internally, it was new for everyone, and we wanted to make it easier for users to be able to use Elmer and for creating chat applications either with Shiny or without Shiny. So Joe Chang, he wrote this app called Elmer Assistant. And I'm Elmer Assistant. I'm here to answer questions about Elmer and Shiny Chat or generate code for you. So let's say, create a simple chat app for the console. So this will be a chat app without Shiny. All right, so it's emitting some code here and some text, and it's just showing us how to do this. Now, the interesting thing, though, is that the LLMs themselves, like from OpenAI and Anthropic, they don't know about Elmer. Their training data stopped before Elmer was released even for the most recent models. So, but we have here a chatbot that knows about Elmer and is helping us write Elmer code. Well, how do we do that? Well, the Elmer readme is basically copied and pasted into the assistant's system prompt. So let's take a look at what that system prompt looks like. All right, so here's the system prompt. You are an assistant that helps write code for Elmer and our package for interacting with LLM APIs. There's more text here. But then down here's the README for tidyverse/Elmer. Okay, and at this point, that README is just copied and pasted into here. All right, so there's a lot of stuff here. I think there's some other, there's some vignettes for the package also that are in here. There's quite a bit of information. So all of this information is sent to the LLM when the user makes a request, and that is how it's able to answer questions that the user has about Elmer. And it helps, like, because the documentation is good, that helps the LLM give good responses. So that is, that's yet another reason to write good documentation, is not just for other humans directly, but for LLMs, so they can ingest it and then help people write code. Another example of this is brand.yaml. So Garrick Adenbui gave a talk about this today, I believe, and he has created a prompt for brand.yaml just specifically for LLMs. This one's actually quite a bit shorter than the Elmer one. And if to use it, you just copy this code block and then paste it into, well, you can paste it into the chat interface or use it as a system prompt. So, there's this is the information about how to use brand.yaml. So this is really great, because if you're building tools that need to know about brand.yaml, all you have to do is copy and paste this in there. And it's actually not, this is not too big. So it's very useful. All right. And so that's how you can teach them about more information than the LLMs know by, from their regular training. Okay. All right. So those are some of the concepts that I think are very important to know about working with these LLMs. And I hope that, that helps to demystify some of this, some of the things about LLMs. And for me personally, it also helps me view them as being less scary. They're just sort of like, they're just tools for helping, helping us do things. They're very interesting, very powerful tools, but they're not magic. All right. And it's not like there's some like robot that's just sitting there thinking about how to like dominate the world or something. It's when you feed it some text, it's going to give you some text back. Although I guess the things that you can do with that is actually quite impressive. So, so that is something interesting to think about. All right. All right. Next up, let's talk about AI tools for building Shiny applications. All right. Now, I want to say that I think that Shiny is at the right level of abstraction for AI-assisted coding of data applications. Now, what do I mean by that? What is the right level of abstraction? Well, even if the AI is generating code for something, this code still has to be checked by a human in order to make sure it's doing the right thing. So even though LLMs can generate JavaScript, and like the LLM tools for generating JavaScript and React code, they're really good. They can do very, very, very impressive things. But even though they can do that, if you're being responsible at all, you have to be able to verify that the code works. And if what your goal is like, hey, I'm not interested in, creating the flashiest interface or, some really customized thing. I'm trying to get this data project done. That's sort of noise, because you still have to verify that all that works. And that's another thing that you would have to learn, like, learning JavaScript and React and all that. If you're using those tools, if you're writing that kind of, if you're using your AI to write that kind of code, you still have to, you'll have to understand those things and vet all that code. But that's not necessarily the important thing that you're trying to get done. So for data scientists that are working on data applications, Shiny has a good balance of readability, so that you can verify what the AI has done, and flexibility, so that you can do a lot of the interesting things that you want to do. Okay, so let's take a look at the AI coding landscape. So there are like these web chat interfaces, which I'm sure everyone here has used. There's like ChatGPT and Claude on the web. And if you're using those to help you write code, it's it's a bit of a manual process getting your questions in there. Like, you might have to copy and paste your code to get it in there. And then if it generates some code, you might have to copy and paste it to get it out. So these tools are those web interfaces are very useful, but they're a little bit of a manual process to get stuff in and out of there. Okay. There's also some command line tools that you'd use in a terminal. There's Aider and Claude Code. Those ones are, you tell them what you want, and they'll go and look at all your source code and like make a bunch of modifications. Those are some pretty interesting tools. There's coding assistants in code editors. So probably the most well-known of these is in VS Code. These days, it ships with GitHub Copilot. Although I think you still need a. Oh no, sorry. I was going to say I think you need a subscription, but I do believe there's also a free tier for using Copilot. Let's see. There's also the RStudio IDE can use Copilot if you have a Copilot subscription. There's VS Code. There's a bunch of VS Code extensions. So you can see a lot of this is happening around VS Code. There's VS Code extensions like Continue, Klein, Codium, a lot of things that start with a C. And there's forks of VS Code like Cursor and Windsurf. So these are basically derivatives of VS Code itself, where the VS Code extension mechanisms were not flexible or powerful enough to let them do all the things that they wanted, because they wanted deeper AI integration. And also positron, possibly at some point in the future, which I can't say too much about, but I thought I'd mention that. Now, okay, what are some of the limitations of these tools, and specifically limitations for working with Shiny? Well, one thing that's important is that current LLMs are not good at Shiny for Python. There's part of the reason for that is there's just not that much training data for them for Shiny for Python. There's a lot of like R Shiny stuff that the R Shiny has been around for over a decade, and so there's a lot of stuff out there. When these companies scrape the web, there's a lot of examples that they can learn from, but not so much for Shiny for Python. Okay, they don't know the latest features and libraries. So these LLMs, they don't know about like Elmer and Chatless and all these Shiny chat UI components. So typically when the new LLMs are announced, the training data usually has stopped about 6 months before. So, the companies that get the training data, they scrape the web and to gather a huge amount of data, and then they start training the models, and that training takes time. And during that time, they're not like getting more data to feed into the models. And like even if Shiny had new features that say were like 2 months before the training data cut off, the LLMs might know something about it, but that's still not enough time for there to be a lot of training data out there for the LLM, because people might have just started using this, whatever new features, and so there wouldn't be a lot of code to use for the training data. So really, these limitations are more about the LLMs than about those tools that are built on the LLMs. But these are important limitations. So last summer, we were looking at this, and we thought, okay, well, maybe we can build something that works better for Shiny. And so out of that came Shiny Assistant. And I don't know if everyone here has seen it, but this is Shiny Assistant. It's a chatbot, but it's also a little bit more than chatbot. So let's have it write some R code. So I can ask it to create a Hello World app, and it will move over to the side and open up Shiny Live. This is Shiny Live is Shiny where both the server and the client portions are running in the browser. So in this case, R is actually running in the web browser, not on some server somewhere. Okay, so here it created a Hello World app, but this is not being escaped properly, so we can tell it, we could go through this and we could tell it to fix some of these things and tell it that it's displaying this in a funny way. But yeah, so this is what Shiny Assistant can do. It can, and we can ask it to iterate on this application that it created here. So what are the things that are part of Shiny Assistant? Well, the most critical component is having a good LLM model. So right now that's Claude 3.7 Sonnet. When we first built this last summer, it was Claude 3.5 Sonnet. And that was the first LLM model that was good enough to actually generate decent, have a good chance of generating decent Shiny code. That was a big step up when it came out. All right. The next really important component is a customized system prompt with information about Shiny. So, as I mentioned earlier, these models were not very good at, the models by themselves don't know very much about Shiny for Python. And last summer, they knew even less. A lot of the time, you'd see that, oh, Shiny for Python doesn't exist. All right, so we had to customize our system prompt with information about Shiny. Shiny for R and Shiny for Python. Okay, now it's also integrated with Shiny Live. So Shiny Live is, it's this whole thing here on the right under this blue header part. And Shiny Live is really nice for this because it has a code editor built into it. So when the LLM generates code, you can go and edit it and change it yourself. Because sometimes, a lot of times for these code generation tools, the LLM generates code and then you can't edit it. And if you want to make even the slightest change, like the change to a color, you have to ask it to do it. And sometimes it's just more efficient to do it yourself. All right, so it comes with a code editor. It will run the application, and all of that happens in the browser sandbox. So, and that is all. It's all very efficient, and it's safe. It's in the browser. The browser sandbox. That's something that's been battle tested for security, at a level that would be very, very hard for any other type of thing to replicate. People are using web browsers all the time and trying to hack them. So the browser sandbox is very secure. Now there are some limitations. Shiny Assistant. Oops. So, first among these is it still doesn't write perfect Shiny code. If you use Shiny Assistant, I'm sure you've experienced this where, we just saw it just now. Like it didn't escape these HTML tags, right? It just stuck them in there. And oftentimes you can ask it to fix it, and it will be able to do it, but sometimes it won't. All right, and that's something that perhaps newer LLMs will be able to do better, and perhaps we can improve that by working on the prompts that we give them. There's also data privacy concerns. So right now, all of the code and data in a Shiny Live app is sent to the Anthropic's API. Like when you ask it to make changes to the code, like right now, if I asked it to do something, it would send this whole app code to the Anthropic API. And it currently sends all of the files that are in here. But you can have multiple files. It'll send all of them to Anthropic. And we could actually improve that, and we could change that behavior. But for simplicity, that is how it works right now. Right, there's some limitations because Shiny Live runs in the browser. So I was telling you about the advantages of that before, but there's also some limitations. So first off is it can't access local resources like files and databases. So if you have data on disk, Shiny Live applications are not able to access them. You could run your Shiny. You could copy and paste that code into your regular code editor where you save it on disk and you run it like a normal Shiny app. But then you're sort of taken out of that really quick iteration cycle with Shiny Assistant. So you can't generate the code and then copy and paste it elsewhere to get around this. It's a little bit awkward to modify existing apps because you have to copy and paste your code into Shiny Assistant, into the code editor, for it to know what the code is, and then you have to copy and paste your code out. Okay, there's restrictions on network requests, and this one is actually particularly important for AI stuff because we can't use these LLM libraries that make network requests. So, like in the Python world, OpenAI and Anthropic have libraries for talking to their LLMs. In R, Elmer does that directly, but those libraries, those packages, although it's possible for a browser to send an HTTP request to those LLM servers, these packages, they actually import libraries for that communication that can't run in the browser. So it just means that we can't use those libraries to talk to LLMs. And for that reason, Shiny Assistant doesn't know about Shiny Chat developments. So we could hypothetically update the prompt to know about Shiny Chat stuff, but we haven't because it'd be just disappointing where it would generate this code for people, and then that just would just not work in the browser when they're using Shiny Assistant on the web there. Okay, and I also need to mention Epsilon Flow. Peter Strozenko gave a talk about this today, which unfortunately I was not able to watch since I was working on some last minute touches to these slides. So I know that they have their way of dealing with some of these issues, but I'm not able to intelligently comment on that. But I thought it was important to mention it here. And I've seen some of the stuff that they've posted about it on LinkedIn, and it looks really interesting. Okay, so that was with Shiny Assistant for the web. Now, we've also been working on something called Shiny Assistant for VS Code and Positron. And Positron support is coming soon. All right, now let me give you a little demo of this. Okay, let me just work on my screen sharing here. Okay, so this is, let me see. Okay, so this is what it looks like when you're using it. So Shiny Assistant for VS Code actually works in Copilot. So if you have Copilot, if you use Copilot for VS Code, you'd open your chat thing here and you say @Shiny, and let's ask it to build an app for us. So create a simple AI chat app. Okay, let's tell it which language we want. Let's do R. Oops. Oh yes, this is sorry, that is a bug with the Shiny extension that was just recently introduced, and I will fix that soon. Okay, so it wants to, now it's asking us where we want to put this application. Do we want to put it in this chat app subdirectory? Sure. Okay. Okay, so it'll tell us, give some instructions about what we need to do. We need to install some packages. Now, I actually already have those installed. It tells us to create a .env file with API keys in it. Actually, I've already done that as well. And then it's generating the code. Let me move this a little wider here. Okay, now after it generates the code, you can view these changes as a diff. And if it all looks good, which it's creating file new, so it's fine, we'll hit apply changes. And then let me make this a little smaller there. And we can run the application by hitting that play button. Okay, now, oh, you know what? It is, I think it's missing something. Well, let's see if it can, okay, let's see if it can fix this. So this is something that happens. I knew I was taking a risk by doing a live demo here, but let's give this a try. I hope this works. It says, let's just paste that in there. There's one way you can work on fixing issues with AI. Yep, so it correctly diagnosed the problem. We needed to add the bslib package. All right, so these are the changes, and I'll just apply those changes, and I'll run it. Okay, oh man, so cannot find envar opening. Oh, sorry, I didn't read the instructions carefully enough. There was I actually have to copy this .env file to that directory. So copy, paste. All right, 4 times the charm, please. Oh my gosh. Oh. All right, here we go. Okay, let's see. I know what the solution is here, but I'm going to see if it can figure this out as well. Okay, so it's telling us where to get the API key, and then okay, about .env. I guess I have to give it a little hint here. Okay, so this is it figuring out what it needs to do and has to load this .env file. Okay, so there we go. This is our AI chat app. A little bit more work than I was hoping, but it is here. So let's see. Tell me a very short story. Okay, so this is working. It is talking to GPT-4o from OpenAI. All right, so you can build these AI chat apps this way, and you can also, you can ask it to do some customization on it. So let's say, okay, I'll talk to it. Make it speak like a pirate and play the game 20 questions. I also want the system prompt to be loaded from a markdown file on disk. All right, so it's going to think. All right, so now it's creating a system prompt for us. That's actually really nice. Sometimes it can be hard to sort of get started creating a system prompt. So I'll just apply that changes. There's a prompt. It's also making some changes to our app.r file. Okay, let's just apply those changes. Okay. Prompt MD. Oh, did it save this? Oh, let's try running this again. Waiting for ShinyConf to start. Oh, you know what? I'm sorry. It's trying to read from the wrong directory. So again, you have to bring your debugging skills to bear here. It won't always work on the first shot every time. Although I will say I did have better luck when I was practicing this earlier. There's a risk of doing a live demo. All right, so wow. It's even colored this for me. That's kind of cool. All right, so now you can play 20 questions with this. I'm not going to do that right now, but I want to mention that once you have it in this state, I've got this system prompt in a separate file. I can modify this and insert documentation about other software projects in here. So if I wanted to teach it about some new software package I'm working on, I could just copy and paste it in here and tell it to answer questions about that. All right, and you can also see there's not that much code here. This is actually, a bunch of this is just styling. So the actual code for the chatbot itself is quite simple. So you can create your own custom chatbots this way if you want to teach them about topics that they don't know about. All right, let me move back to the slides. Okay, now to install it, here's how it works. So in VS Code, go to the extensions, and you click on this thing for extensions, type in Shiny up here, click on this Shiny thing that will pop up. It should be at the top of the list, and then click on Install. And it'll install it should install the latest version of the Shiny extension for you. And it does require a GitHub Copilot subscription. All right, and then to use it, make sure it's in Ask mode down. This is a very new feature that they just added to their interface, like within the last week. And then say @Shiny, and then ask it to do things. Okay, so how's it different from the web version of Shiny Assistant? Well, it uses a GitHub Copilot subscription. That's a very important difference. So I know many people have it already, and one thing that comes along with that is that Copilot has an intellectual property indemnity that's provided by GitHub and Microsoft. So for many organizations, that's important. The Shiny app can use local resources like files on disk, if you're in data on disk. It can use network resources. The assistant can modify existing apps, and it knows about new Shiny features like AI chat and brand.yaml. So comparing it to other coding assistants, it's installed as a VS Code extension, like many other of these coding assistants. And it integrates with Copilot. You just type in @Shiny. You don't have to subscribe, get your own. You don't have to get API keys for, OpenAI or Anthropic. The system prompt is customized with Shiny knowledge. That's what makes it work. And it knows about the latest Shiny developments. But it's also not as agentic as some of these AI coding assistants. So some of these AI coding assistants could go out and just read a whole bunch of files and change a whole bunch of stuff. And Shiny Assistant can do a little bit of that, but not as much as these tools that are built for that specific purpose. Okay. All right. So that's it. We've talked about writing Shiny apps that use AI, using AI tools to build Shiny applications, and how these conversations with LLMs work. So I hope you all learned a lot from this and are excited to use Shiny with AI. And thanks for listening.
Thank you very much, Winston. We have plenty of questions from the audience. We might lose some context, so I kindly ask authors that if we struggle to answer, to put some more context in the chat. So let's start with Matteo. Does this increase the token cost because each request compounds?
Yes, that is definitely the case. Every time you send a request, it's each time you're sending a larger and larger payload to the server, and that is just how they work. Yeah, it's unavoidable. I mean, there are techniques that people use, like they might ask an LLM, "Hey, summarize the previous steps in the conversation for future use," and so the LLM can do that, and you use that summarized version later on.
Okay, extending on this question, if we have this big payload in the system prompt, is it also including to the total cost of the used tokens?
Yep, that definitely counts as well. But Anthropic has a prompt caching mechanism where you can cache prompts, like a conversation up to a certain point, and if it sees like another conversation that has that same stuff in the beginning, then it'll draw it from the cache, and it costs I think it's like a tenth of what it normally would cost. So there's and OpenAI does some caching as well. Their mechanism is a little different. But yes, it's just, if you have a very large system prompt and you keep sending it over and over again, it can add up for costs.
Okay. Zuhaib is asking, is there a limit to how far back into the conversation it can look?
Yeah. So so the best, the state of the art models these days, they have a limit of like about 128,000 tokens for OpenAI, 200,000 tokens for Anthropic, and a token is a token is like a part of a word typically. So let's say it's like, I don't know, it translates to maybe typically around about 5 characters on average, I believe is the correct number for that. And so there's a limit to how far back you can go, and even if all of your information fits in that context, the LLMs are not perfect at recalling all of that information. Especially like there's the Google Gemini models have context length of like 1 million or 2 million tokens, and my understanding is that when you're getting up to that size, the recall of the stuff in those prompts is not always very good.
It might relate to the Josh question. As the conversation continues building a longer history, is there an increased potential in hallucinations?
I don't think there's an increased potential for hallucinations. In my experience, it might not remember everything perfectly in that history, but I don't think it makes it more likely to just make things up. So but although when that does happen, that is kind of alarming. Like when like the chatbots just make up stuff like URLs that don't exist, and sometimes you don't realize that until you're well into a project, and you're like, oh wait, this is all completely made up.
Right. Steven asks, how do you deal with preventing accidental exposure of API keys?
So typically, well, that's actually one more reason we didn't have Shiny Live on the web version of Shiny Live talk to these AI LLM providers, is because the API keys, those should be stored on the server, and the server, like the server that's running Python or R, that server goes and talks to the LLM endpoint. And that server, I mean, it's common practice for the server side of these applications, of all sorts of applications, to have various secrets like API keys and things like that, and that you treat these in just the same way. But you don't usually put those API keys, send those to a web browser. So because then if you sent your API key to like your user's web browser, then they could just use your API key for whatever, and you don't want to do that.
Absolutely. James' question. Llama 4 Scout has a 10 million context window. Could you in theory pass a GitHub repo into the system prompt and have the module understand the entire repo?
Yeah, I mean, there's tools that help do this. One of them it's a JavaScript project called RepoMix, and people do that sort of thing. I don't know. I haven't used Llama 4 Scout, but again, my understanding is that when you get to very long context lengths, they're not going to have perfect recall, but they will learn something from it. Like if you want to, probably if you do that and then you ask some questions about it, it will be able to answer them, but perhaps not. It might not remember every single little thing that was provided in the system prompt, though. But sorry, I have to add one more thing. Really important thing. Working with these LLMs, it's a very empirical process. Like you don't know what they can and can't do until you try it. Sometimes we think they can't do something, and that seems hard, but you try it and they can. And the reverse happens. Sometimes you think they should be able to do something very simple like adding numbers, and they can't do that. So yeah,
it changes also with new models, right? Something that worked for you before is changing a lot.
It makes it hard to program against them. Yeah.
Okay, Phil, we ask, does it mean you won't need to send the documentation inside the prompt in the future when the models are updated?
Yeah, I mean, hopefully, I don't think, hopefully they'll learn enough about, Shiny for Python, all this Shiny chat stuff. Hopefully their training data will be updated and they will learn enough about it that we don't have to supply a ton of that documentation in the system prompt. Like they don't, for the system prompts, they write very good JavaScript and React code, these LLMs, and they don't stick that in the system prompt. There's just so much good training data out there that they can just do it. So, I mean, we probably won't get to that level of popularity, but hopefully it'll be good enough that they'll do a decent job.
Right. Thanks. And the next one, do the web chat interfaces work in the same way described earlier, stateless server-side and sending the entire conversation history with every message?
Yes. Yep. So the web chat interfaces, there's the LLM part of it, and then there's like this web application server, that layer that's built around it. So that that web application layer will save like previous conversations that you can go back to. They'll provide some tools like searching the web. So that is the like the ChatGPT web page or website, but the ChatGPT API that you can talk to in the way that I showed, that doesn't have any of those features. So yeah, so the web application does a lot of these things that I was talking about, like building up the message history and things like that.
Sebastian asks, can you show us how to update the system prompt with information about Shiny?
I can, although I'll post some slides and some links after this. I'm not sure. Well, maybe you can tell me later how best to do that, and I can point to some of the prompts that we're using for Shiny Assistant.
Okay, we can take it offline in the backstage. Yep. Martin is asked, what about O3 Mini High if compared with Cloud Sonnet for Shiny code generation?
Oh, O3 Mini High. I've heard that's good, but it's slow because it's a thinking model. So there's like this dialogue that happens. It sort of like talks to itself behind the scenes, I believe. And I have not tried it myself, so I can't really comment on that. I mean, Cloud Sonnet models have been really good, but the O3 Mini could be really good as well.
Great. Thank you. And a question from Veronica. Is there a remote possibility that in the future these LLMs models cannot be improved because there won't be an example out in the web to learn new things from, just because everyone used the LLM models to solve their issues and not sharing the knowledge anymore?
I am not, I'm not like a deep expert in that side of things. I've heard that that kind of thing is possible. Although some of these models, they are getting better, even though the models aren't getting larger, and there's not like a whole lot more training data that's coming into existence now. So part of it is like better training techniques, maybe better architectures. But yeah, are they going to hit a limit? Maybe they'll have to resort to other techniques like having these models try things, like actually try building code or writing code and then running it and then doing some reinforcement learning on the results that way. So yeah, but again, I'm not an expert on it. That's just sort of, my thoughts about it.
Personally, I feel that there will always be some just people who like doing such stuff and sharing it, so I think there's always something coming from humans.
I hope so.
Question from Josh. What is currently being done to alleviate some of the current limitation of Shiny Assistant?
So there's the Shiny Assistant web version, and then there's Shiny Assistant for VS Code. So there's those limitations that I listed, and the biggest one is, I think, not being able to, for the VS Code version, not being as good at writing Shiny code as I would like. As you saw in the demo, which was actually, I do have to say, that was actually, they had many more errors than I expected from my practice runs through this talk. But that is also, it also shows, like, here's how you have to work with these things. Like, they're going to make mistakes, and you're still going to bring your brain there. So will they get better? I mean, so we are working on improving the system prompts for them and putting more information, and not just more information, but like efficiently showing them with the right way to do things, so we're not just filling up the system prompt with junk. And that is a long process, and we're going to keep working on that. But again, then a new LLM model comes out and they behave differently, and then you sort of have to redo a lot of your work again.
Absolutely. Question from Tyron. I guess it's related to demo. Is this running via extensions or MCP?
This is the Shiny Assistant for VS Code that is running in an extension. So it actually uses something that Microsoft has in VS Code called a Copilot chat participant, and that's what the @Shiny is. So it just runs as a normal extension using those features.
Okay. Just two questions left, and one is from Piotr Storozhenko. Winston, any plans, visions for creating MCP server with Shiny knowledge? I'm not sure how it should work, but I feel it will happen one day.
That is a really interesting idea. I mean, inside of Posit, we've talked about not MCP servers for this specifically, but like creating repositories of knowledge about some of the things that we make, and figuring out how to serve up that knowledge effectively for LLMs. An MCP for that would certainly be one way to go about that. And that's actually pretty interesting. So no plans at the moment, but that's a cool idea.
Thank you. And the last one is from Feng. Can you comment on deep research type of future work?
Okay, I'm guessing that this refers to like OpenAI's deep research. I actually cannot comment on this intelligently because I don't know. I've heard it's very interesting. It can it'll search scientific papers and come up with some really interesting summaries and about it. But I've never actually used it myself, so I can't really say much about
it. Thank you, Winston, for this great presentation and all those answers. It was great to have you here.
Yeah, thanks. This is a lot of fun.